welcome. So who was at the Ignite yesterday? Okay, then I propose a new title for the talk today, Containers, Friends Don't Let Friends Use Kubernetes Edition. So today we're talking about Nomad, the way we monitor it, the way we get metrics, and Nomad I'll introduce later, but it's another scheduler engine, which in my opinion is a lot easier to use than Kubernetes. First of all, let's introduce myself. Back in the day, I used to go to university to become a molecular biologist. I spent some of my time in big pharma, so I sold my soul to the corporate world. Then big data became a thing in molecular biology, so I became a developer. I used to do stats on my data, so I sold my soul. According to my colleagues, I sold my soul to the dark side and became a developer. In academic environments, the developer guy also is the operations guy. Now I'm employed at NETWAYS as an operations guy, so according to my colleagues, I sold my soul to the dark side again. And at the moment, I'm an open source consultant at NETWAYS. That probably means I run Ubuntu on my laptop. No, I do, but that's what we're gonna. That's what I am. That's what we're doing, and this is pretty much what we're gonna discuss today. A lot of lines, but to go through it, there's people on the internet. They want to go to your website, and they need to end up on your Nomad cluster, your scheduling engine. And this is the simplest drawing I could come up with that has some form of server discovery and that has an ingress controller. I'm looking at consul, which is another hashicorp tool, and Traefik, which has integrations with consul, but also Kubernetes, etcd, and other stuff. Introducing Traefik, as I said, it's an open source open source edge router, which means it serves stuff that comes, well, people request stuff and it basically routes stuff to where it needs to go. You can have static routes, but at the moment, today, we're going to be more interested in the dynamic routes because your scheduler will stack it on a node where you have no idea where it's going to end up. That has loads of native integrations, Kubernetes, Rancher, etcd, consul, as I said. A couple of weeks back, they released 2.0, which has none of these integrations. They released it as 2.0, but it's actually in alpha, so the 2.0 only has Kubernetes integration right now, unless they release something this week. If you want consul, what we're going to discuss about, I am assuming you are also using the 1.7 branch, or 1.7 releases. It has native Let's Encrypt integration, so for us people that are lazy, you can basically automatically get your certificates without having to set up the Let's Encrypt client. What does it look like? It's fairly simple. It's TOML. It's somewhere between INI files and a YAML. It's fairly simple to set up. We have two entry points. One's called HTTP, which listens at port 80. And because we're not cavemen, we basically forward HTTP onto the next entry point, which is HTTPS, which listens on 443. For which we're going to set up some Let's Encrypt certificates, so we want SSL. There's a section called ACME with the entry point specified as HTTPS. That's where we need to serve those. The asterisk is about the following setting, the on-host rule, which basically you can request certificates in advance, or you can request certificates at the moment Traefik works out you need a certificate. Normally that's fine. But when you have traffic coming in already, that first connection is going to destroy. Well, no, it's not going to be destroyed. It's going to have quite a bit of latency because before first byte, it's actually going to request a certificate. Most of the time, in a moment we'll see, we'll add automatic monitoring. So monitoring will be your first visitor, so you shouldn't have this problem. But keep in mind, it's requests. The certificates get requested on a live connection. The challenge needs to be on the HTTP endpoint, and then the last line is actually how we turn it on. And now for the dynamic bit, it's actually fairly simple. It's another section called consul catalog. We have a domain. You specify a domain. My case, it's the attachmentuni.com domain, which is my private domain. And we point it to our local console cluster. Console has a nice setup where it's basically there's an agent on every node, and you can ask the local agent question, and it goes out into the network, or actually it syncs the network locally to be able to serve the answer. And then the last one is a security feature, which is true by default, so that's anti-pattern, but exposed by default. So at the moment when we turn on console support in Traefik, what it actually does, it will serve anything. It will expose all the services. So by turning off exposed by default, it actually, you have to make a conscious decision to actually serve something to the general public. If traffic's on your local network, you're probably fine, but in my case, it's actually serving stuff to the internet. So the next one is, how do we turn on metrics? Because that's what we're all about. We want to know what's happening. We want to see our visitors come in. For the people that like dashboards, there's a simple flag, and the other one is metrics Prometheus. That's what we're after. Then it gets on a special endpoint and on a special port that's only available. Well, you have to make it only available locally, but then that's where there's a built-in Prometheus exporter. And ping is what we're going to use in the console check. When you go out to the Grafana dashboard website, you can actually have lots and lots of nice pre-built dashboards already. When I show dashboards, I also show the number of the ID for the Grafana dashboard website. Most of them is really interesting is that they actually split out all the traffic based on the HTTP code, which then we can do nice calculations based on the ratio between 200s, 400s, 500s. Of which then we have nice Prometheus Alert Manager requests. The Alert Manager alerts that tell me if my ratio is off. And I probably should start looking at what's going on. So the next one, console, we pretty much alluded to it already, but console is an open source service discovery tool that most of the time will serve information as SRV records from DNS, so you can bind it into your favorite DNS server, and then based on known domains that are probably not routable in your system, in your environment, you can actually find services. So in my case, I dig my local console cluster for the service Puppet Master. It also has a built-in key value store, which is very nice to use because it actually knows about location. So there's the notion of data centers, and the information will know, the key value information will know what data center you're in. And it recently gained the possibility to have a full ACL service mesh. So you can actually block other services, or you have to specifically tell other services that are allowed to use it. Little Puppet example of how to build it. So in my case, the Traefik UI, I want to expose it because who has the time for command line? So in my case, I want the Traefik UI that's listening on port 80, I want to make sure that it is available in console, because then I can make it available in Traefik. Console uses the notion of service, but it also needs checks. So every service needs at least one check to make sure that the service is active, is live, is available. So it's fairly simple to set up. It's a console check with a name. I want to check it every 60 seconds, and it needs to go out to a certain URL, in my case, just localhost 8080, and it's linked to the service Traefik UI. The nice thing for us, if you are interested in using console, is basically the fact any valid Icinga check is a valid console check. They were clever enough, or they were honest enough to basically steal the idea from Icinga, and they used the same exit code. So in my case, I can actually, we have Or I wrote a Nagios plugin or an Icinga plugin that's called Traefik status, and I can basically replace the script or the HTTP endpoint, and I can do all my magic in that script, and it's still linked to the Traefik UI. Telemetry or metrics. Telemetry, as they call it, but metrics, as for us normal people, that's how they call it. It's fairly simple to turn on. This is it's a 2-3 lines. It will tell you how long the data needs to be in the system. So in my case, it's 30 seconds. Otherwise, it gets flushed. And disable hostname, which doesn't prefix your information but uses tags. Also, nice dashboards. Again, directly off of Grafana dashboard site. Tells you how many nodes you have in the cluster. It tells you what the lag is or between the members. It will show you how much traffic is going around. And first and foremost, it will show you basic numbers about loads, CPU, and that kind of stuff. Nomad, this is what we're after. This is the scheduler. It's a open source tool by HashiCorp. It's to do dynamic workloads, or it actually can do batches. Most of the time you'll use containers, but you can also use Java. And it has native integration with consul and Vault. Similar to turning on telemetry, 4 lines is turning on Vault and Vault is a bit more work, but consul is definitely 3-4 lines where you basically point it to a cluster member, and that's it. Nomad will start announcing itself and its services into consul, and then you're good to go. Whereas I still haven't worked out how I can do it in Kubernetes. Turning on metrics or telemetry in Nomad is, you need to answer a couple more questions, but it's mostly interval, again, disable hostname, and specifically need to ask for Prometheus metrics in this case. Nice little dashboards. The one I use most is this one, which is the 7.8, so 6,278, where it tells me the allocations. Nomad is a system where you have to pre-announce the allocation system. For people using VMs, that's something new, especially us at NETWAYS. Professionally, we do overcommit our hardware. But that's normally fine, but in Nomad you cannot overcommit because you announce your allocations. That's why you need to look at stuff like CPU memory. And then it also tells you what jobs are running, which jobs are trying to be scheduled. So then you ask, of course, we've been talking a lot about it, but what does it look like? A job in Nomad is basically, it needs to have 3 things. The name, it's a job of type blog. It needs to land in a data center, and in my case, it's a type service, so it will need only 1 or 2 running instances. And then there's a group. The group is actually what defines the meat of your job. In my case, I want to run a task called Nginx. That's my container. My container has my simple blog in there, and the Nginx to serve it. So the image itself is about 4 or 5 MBs at max, at its biggest, and I want to serve it from my AWS container registry. And it needs to listen at port 80, or something will be listening at port 80. Then I define the service, because that's the check. So we're the only way for Nomad to announce it into consul is having a check. Consul needs to be able to check if the thing you're announcing actually will work. So similar to the Puppet code I showed before, we need to define a service. In my case, service blog, it will have the tag. So a special tag, Traefik enable is true. This is the tag that I need to pass to actually provide something to the big angry world. So my blog is allowed to go to the internet, whereas other services that are used internally, I'm not allowing it to go to the internet. It listens to the port HTTP, which before we defined as port 80. And in that case, what I tell it is I need to check it every 10 seconds to see if something is listening on this HTTP port. And I define a timeout. Timeouts are required, or very well, you should do it, because otherwise the console will kill your whatever is running, because if it doesn't time out, it will just keep going. And at that point, this is the one I didn't show yesterday, but this is my overly engineered personal website. It does nothing. It has links to my GitHub, my Twitter, and not even my LinkedIn. So this is what actually now landed on the system. We have a running Nomad. We have a service in consul. I'm not sure you guys know consul, but it's the website. It has a list. So my blog has 2 healthy checks, and because Nomad has announced it, it actually has metadata. So there's a nice little logo that basically announces it. This service is running in Nomad. It's not easy to query afterwards. I'll go into it a little bit later. But you can also see it in Nomad. This is what the Nomad UI looks like. In my case, it's the job blog, which failed a couple of times because the cluster wasn't healthy. And now it's actually running. So recent allocations, the task Hugo is running since September. You can drill down, and it will actually tell you it runs on a certain node on port 23,706, which is a random port. Nomad will normally schedule your service somewhere on a port somewhere between 20,000 and 32,000, which actually introduces the nice little problem we have now. Is the scheduling is very dynamic. So we can actually draw a line, sort of drew the line already on the screen, but to the left is pretty static. On the right is going to be very, very dynamic. If you run, well, you're more likely than not are going to run these Nomad clusters in an auto-scaling group, because that's the easy part. If your monitoring is going to see you're running out of resources, the easiest thing to do is just stick it in an auto-loading group. Credit card limits provided, for credit card limits, keep in mind those, but otherwise stick it in an auto-loading group. And then it's going to be also landing on dynamic ports. So that's a problem you need to solve, or we need to solve. Normally, the systems we're using, they're pretty static. They get set up, and they're pretty much static, non-changing the rest of their life. Sometimes we add a new node, but we're fine with that node not showing up in monitoring in the next 10 minutes, 20 minutes. Nomad scheduling can happen at any point. So there's mechanisms to reschedule stuff, to move workloads around, to create space, to empty nodes. And that's where our monitoring is gonna suffer, because the standard ways of doing stuff is not gonna catch up quick enough. So I wrote a Icinga director plugin that actually queries consul. This is, well, it does more, but this is the meat of the module. It basically, I stole some code, I reused a module from someone else. I basically creates this factory and then goes to consul, requests the catalog, which is one of the functions, and then it asked, can I get all the nodes that are currently in the catalog? So the catalog is where consul does its administration. That's where it knows where the services are, that's where it knows where the nodes are, that's where it knows where the checks are. So I just ask where are all the nodes, and then it gets passed into director. Director is fairly easy to set up. We have a new import source called consul, which feeds off the module I wrote, and then I just need to point it to the local consul cluster. And now I see I used the wrong screenshot. But basically, they have a sync rule where I import hosts of type host I want to replace, and I want to purge. And then I actually have a filter expression to only import my Nomad nodes. With this this sync rule, because everything else is pretty much static for me. So this is the only stuff I would really want to use dynamically. Then I need to sync some properties or map some stuff from the console information onto Icinga. So making it useful in Icinga, I need to map the address from console onto the address in Icinga. I need to apply a basic template, which my imagination went to dummy. Dummy does CPU, does memory, does all the standard stuff. And in my case, dummy actually is the Nomad role. So I used it's a terrible name. But when it does, it checks if Nomad is live. It will check if there are services, if all the jobs. Sorry, I should say all the jobs are actually running, and it will alert me if there's failures. Not sure how familiar you are with Director. Director also needs jobs, which are easy to set up. And now in the newest Icinga, there's actually a service that now runs the jobs for you. Otherwise, I had some console watchers to actually check if it was going. Speaking about console watches are, well, it's actually pretty much self-explanatory. Console watches something for you and then acts on either the service changing, the events firing, nodes appearing, nodes changing, nodes. And in my case, I'm actually also a big fan of the Icinga process. I keep forgetting the process. It's basically the squares where it's partly management portal, but it's a summary of basically the underlying services. I don't need to show a big matrix of all the nodes, and if they're all green, I just want to know, is my service up or not? The business process. I get there in the end. Business process definitions is actually a fairly simple DSL, and it doesn't get written into the database. It gets written to a file on disk. So I actually created. No, it doesn't. So I found the file on disk, and I worked out what the DSL was, which is pretty simple. There's a name, there's a separator, and then there's the service names. So I know, in this case, I set up a watcher that looks for new Nomad clients. So it needs whenever a new Nomad backend shows up, or in Nomad nomenclature, it's called a client, something that can serve services. If I see one of those show up, I need to rebuild the business profile, business process UI. So what it does, when it notices it, and this is sub-second changes. So when it notices the something happening in the service, it rebuilds, it goes out to console, gets the information I need. So in this case, it's the service names and the nodes where it runs, and then it rebuilds this file on disk. And then, because Icinga is auto-loading, it's basically next time Icinga reloads this page, you have your nice new view with your new nodes in place. And that was it for today. My name, email, yell at me on Twitter. Do we have any questions today?
Thanks a lot. Yeah, excellent introduction for my question session. Are there any questions? Come on. I already showed off by throwing it far into the back. I want to do it again. No questions at all. I guess we are already a little bit behind our schedule, so I guess we will just close here. And you can get in touch with Bram, I guess, all the day?
I have a 5 o'clock train.
Okay, so just get on hold of it. Thank you again.